have Jim Green, Director of the Planetary Sciences Division, who is going to give our keynote. He had very much wanted to do this in person, and I know really regrets not being able to be here. We've had many conversations over the last months, and I know how supportive he is of this conference. So without further ado, Jim, please take it away.
Thank you very much, Greg. I just want to make sure you can hear me. So get a thumbs up from you.
Yeah, we can hear you, Jim. Thanks.
Thank you. Super. Yeah, indeed. I really wish I was there. Phobos and Deimos are actually very special objects in our solar system and are probably going to play important roles not only in upcoming science activities but also exploration. Some of the things that we've been that's already being discussed at the conference I want to touch on. From a science perspective, it's well described, Phobos and Deimos in the planetary decadal. It's really all about origins. Are they captured asteroids? Are they leftover material from the accretion event? And of course, that means surface material are really important to be able to bring back. Phobos sample return is, I think, in our future. Many of the agencies have actually tried to do that. New plans are coming out to indeed move in that direction. That's what really is focusing a lot of our attention to try to facilitate that in some way. Obviously, Mars ejecta has increased over time as Phobos orbit has decayed and gotten closer to Mars. The ejecta is concentrated in the upper meter of Phobos' regolith over its history. Even if it's an accreted material, it's the ejecta material has been laying on it. Some of the studies even indicate that it's probably evenly distributed around the body. And of course, there's aspects of space weathering that's occurred in that material too. So really, return samples of Phobos would provide data that is highly complementary to that of both the SNC meteorites and surface samples we hope to be able to return. Of course, with 2020, we're working on that very hard. The difference, of course, is Mars ejecta on Phobos will be from sites widely distributed across the planet and therefore provide us different types of information in comparison with the specific samples we'd want to return from Mars 2020. When I look over the history of robotic missions to Mars, there have been several dedicated missions. Some have actually failed way too early and not achieved their objective. I note Mars Express is probably the one satellite that has significantly provided really good sets of observations since it has an opportunity every once in a while in its orbit to get close to Phobos and take a variety of images. New missions are coming on, like ISRO's Mars orbiting mission, and of course in the future the Martian Moons Explorer that JAXA is contemplating now in its early stages of formulation is moving towards giving everyone an opportunity to continue on with the hope that we can actually bring back samples scientifically. But the other side of that, of course, is indeed exploration, human exploration of the Mars environment and on Phobos and Deimos in particular. How that's measured over time is in terms of gaining knowledge necessary to explore those is quantified in what's called a strategic knowledge gap. That's an unknown or an incomplete set of data that contributes to a risk or cost to human exploration missions. And what's been happening, of course, is scientifically we've been really filling in those strategic knowledge gaps. And so where are we in that process? Well, when I look back and see these strategic knowledge gaps. Of course, they're primarily about Mars, from atmospheres to hazards and landing sites and dust, and types of things that you can do with in situ research utilization. But there's a whole section of strategic knowledge gaps on Phobos and Deimos. You know, I've often said, particularly in this building, that Phobos and Deimos probably are the space stations of Mars. You know, maybe soliciting some excitement from human exploration. That's my hope, of course. And indeed, there's just a tremendous amount to learn about Phobos and Deimos. So when I step back and we look at the 50 years of Mars exploration, where are we in filling these strategic knowledge gaps? And it's largely down to a few things. Phobos and Deimos are one of them. You know, if you look at where we've been, where we've had no data and mostly unknowns, and then where everything is really in great shape and we're now ready for human exploration, we're about at the 75% level, maybe even as high as 80%. So we're making just tremendous progress as we move towards potentially providing all the, scientifically, from our missions, all the data necessary for human exploration of this particular environment. When I compare what we're doing on the surface, one finds that we have defined an exploration zone. This is where you land in one site, you live in another area, you do a variety of science, and there's a variety of ISRU activities. You know, perhaps on Phobos and Deimos, when we realize that how they will fit into an overall plan of human exploration, something similar to this will occur. We're making really tremendous strides in finding landing sites on Mars, and in fact, we've had our first landing site workshop last year at LPI. Here's an overview, a Mercator projection, of course, color meaning from laser altimeter measurements, and the sites that are being considered now for human exploration are just at such a wide range across across the environment. You know, our hope indeed is to be able to get to the point where we'll have these kind of maps for Phobos and Deimos, and we'll understand where they fit in an area of human exploration, and be able to chart a course to explore those. You know, they're more accessible than the surface of Mars, and perhaps they might be the first that are observed up close with from a human exploration point of view. I think we need to be ready for that potential opportunity to include human exploration of Phobos, and perhaps even Deimos for that matter too. So many of these things are going to be discussed in much more detail. I really wish that I was there to enjoy the conference and learn about some of the latest discoveries that are being made of these two important bodies. So with that, let me spend a little time answering any questions you might have. Thank you very much.
Thanks very much, Jim. We sure appreciate it. So there's got to be some questions, I would imagine. Please come to the microphone, if you could. I think, Jim, that people are rather quiet. It's just the post-lunch period. Pascal is coming up to ask a question.
Hi, Jim. Pascal Lee here at Ames. Just a quick question. NASA has issued a salmon call to invite proposals for, I think, a gamma ray spectrometer / neutron spectrometer to be on board the JAXA's MMX mission. So that's great. And can you maybe comment on NASA's thinking about how we might do more in the area of Phobos and Deimos in the upcoming years?
Yeah, thank you very much, Pascal. Let me clarify what we've done so far. Right now, JAXA is indeed studying at very early stages the opportunity to go to Phobos and Deimos, thoroughly analyze gravity, mineralogy, look at places to be able to get down to the surface and bring back a sample. This is just a tremendously exciting mission. It's called the Martian's Moons Explorer, and we've been invited to participate. So when we learned that we had the opportunity to participate, we issued a notification to the community that we would release a salmon at an appropriate time. We had hoped it would be sometime this summer, but it also has to be within step of how the formulation of that mission is going on in JAXA. So that promise hasn't changed. We do indeed plan on releasing a salmon that would call for gamma ray and neutron spectrometers in support of that mission. So we're very excited about it. We're just delighted to be been asked to be part of that mission, and we want to work with JAXA and help them any way we can to make it a success. So stay tuned.
Thank you, Jim. Are there any other questions? It was a rather boisterous group, I think, in the morning, but people are kind of quiet right now. And do we have any other questions for Jim? Yeah, please.
Hi, my name is Steph. I'm a PhD student at the University of Colorado in Boulder. So recently, I think we've all heard SpaceX has claimed that they want to put a man on Mars, pretty soon. As a man in your position, how, let's say, skeptical are you that they might be able to actually do this before NASA will? Thank you.
Okay, that's a really good question. I don't think skepticism has anything to do with it. It's really excitement about exploration that extends across our population. Elon Musk is in a position to do something. What he says publicly, he works very hard in completing. Now, with respect to his announcement that he wants to land a Dragon capsule on Mars, coming up in the near term, perhaps at the next opportunity or the opportunity after that, we have been working with them through a Space Act agreement that allows us to be able to trade information, to be able to help him get there. Navigating to Mars isn't trivial. We also have tracking assets. We also have imaging assets. All will will continue to be used to be able to help Elon select a landing site, look within the upcoming windows of when he actually, after he gets his Falcon 9 Heavy up and running, then and only then, of course, could he send a Dragon capsule there. So we're very excited about it. I think even though humans will not be in the capsule, the concept that here is something that could have housed humans and it's being landed on Mars is going to be tremendously stimulating. So we're very excited about it, and as I said, we want to help him any way we can to be successful. Now, NASA has a variety of other plans. It has a capability and an infrastructure it's building. It's all about going to Mars, living, working, and returning. And that's a significant architecture. It's not just about landing Orion on the surface. So that's going to take a little longer. But these things are important steps, and we just really are very excited about his announcements and want to help.
Thanks, Jim. I'm going to take the opportunity to ask the next question myself. Thank you for talking about the Japanese mission. We have, in addition to representatives from Japan, we have representatives from, I believe, either 8 or 9 other countries here. And I wonder if there are other targets that you might have personally, and whether there's anything we can do to help.
Okay, so working internationally is really critically important to us. There's very few NASA-only missions, and we try to work very closely with our counterparts in the other agencies to be able to provide a variety of capabilities, whether it's instrumentation or it's navigation or it's tracking. I think that kind of sharing of resources is incredibly important. It reflects the fact that our science community is international too. So I think we're doing a good job in that particular area. Mars 2020 has several major international instruments on the rover. Such as Spain's developing Meta, Kness is involved in SuperCam, the Norwegians are building RIMFAX. So we're going to continue to do that. We want to continue to provide opportunities with our partners. We're in a lot of discussions about joint Mars missions, and I think over the next couple years we'll see a lot of those begin to solidify. So I think it's just a really great opportunity for us to work together. Future really looks bright in this area. I see in the chat window questions come in. Marguerite's asked, do you think that a human mission to Phobos or Deimos could happen before a human mission to Mars itself? Would there be benefits of such a mission for science itself and or in preparation for a human mission to Mars? Yes, I do believe Phobos and Deimos are probably on that path to be visited first. There's a variety of science that can be done at those bodies, bringing back selected samples, larger samples, being able to perhaps interrogate further below the surface in ways that would be important for us to understand many more things about the origin of either Phobos or Deimos, depending on what we go to first. I believe they're definitely in the thinking right now. They're in what I would call the option space. They're something that needs to be discussed, looked at, explored, perhaps on the path before we get to Mars. But those decisions, we have time to make them. The only way I think we'd be able to make them in an important and educated way is to complete the strategic knowledge gaps of those two bodies that human exploration is really needs our help to be able to do. So we're sort of on the critical path, and I'm hoping we can make some great progress in the next several years in that area. Any other questions?
Yeah, there's one more from Andy Rifkin.
Hi, Jim. I saw earlier today that progress is being made on studies for a 2022 Mars orbiter. I'm wondering if, given we're talking about Phobos and Deimos here, if a 2022 Mars orbiter happens, if there would be any provision for allowing it to study Phobos and Deimos.
Good question. Good question. Right now, we've asked industry, particularly those industries that develop ComSats on a regular basis orbiting the Earth, to leverage their capabilities and looking at what they would do to provide their structures that would be enabling for communication at Mars. So these are just the start of some interesting industry probes and studies. They'll hopefully inform us of the way to go forward. We're thinking about Phobos and Deimos as objects that are important, and we'll take every opportunity to observe them as they present themselves. What would be critical, of course, is that we get a little further on in studying what the next Mars orbiter might look like to be able to determine how its capabilities are going to progress. For instance, one thought has been that that particular orbiter also have the opportunity to leverage ion propulsion. This gives it great flexibility to be able to transition to a variety of altitudes for which Phobos in particular, perhaps even Deimos, would be prime targets. So let's see how these studies roll out, and as we go further into studying the capabilities of such an orbiter, we'll definitely keep that in mind. Yes, John?
For a moon a little closer to home, on international cooperation, I understand that there's a plan for an instrument call for the Korean Polar Lunar Orbiter. Could you give us an update on that one?
Sure. All I can tell you about that is that's coming from human exploration. That's not a call that's coming out of planetary science. So I would defer that question to perhaps the people from HEO that may be at the conference.
Okay, thank you.
Yeah. Victoria, are you in the audience? Ben Bussey was here yesterday, but he's actually on his way to Korea right now as
So,
we...
there you go. It's happening.
It is happening. Okay, we have time for maybe one more question for Jim, if there are any. I'm not seeing anyone. So, Jim, we really, really appreciate you taking the time for this. We're sorry you can't be here in person, but we understand. But I think you'd enjoy it a lot, and the recordings will be available.
Super. Thank you very much.
So, thank you. Bye-bye. Pascal, turn it over to you.
So, folks, at 1:30, we're going to start our robotics reconnaissance session. It's going to be chaired by Amanda Hendricks and Butler Hine.